Have you ever heard someone say, "This car has 1,000 horsepower"? It sounds absolutely insane, right? Like something out of a sci-fi movie. But what if I told you that in the world of electric cars, that number doesn't mean what you think it does? Welcome to the world where horsepower doesn't tell the full story. This is the real power behind electric cars. Let's rewind a bit. The term horsepower was actually coined more than 200 years ago by an engineer named James Watt. He was trying to sell his new, powerful steam engines, and he needed a way for people to understand just how powerful they were. So, he compared them to the most common source of power at the time: actual horses. After some observation, he determined that one horse could lift about 550 pounds, 1 foot in the air, in 1 second. That became the standard for 1 horsepower. It was a brilliant marketing move and worked perfectly fine back then. But here's the thing. That formula was created long before electric motors ever existed. It was designed for a different kind of power. Now, this is where it gets really interesting. Think about how a gasoline engine works. To get moving, you need a complex series of events. You need the engine to build up revolutions. You need to shift through gears. And you need tiny controlled explosions happening thousands of times a minute inside the cylinders just to create motion. It's a process, and it takes time. But in an electric car, there are no gears to shift, no explosions, and absolutely no lag. It's just pure, instant torque. The very moment your foot touches the accelerator pedal, you get 100% of the car's available power. That's the secret sauce. That's why an electric car with, say, 400 horsepower can often leave a 700 horsepower gasoline car in the dust right off the starting line. So let's break down the science a little. Horsepower isn't a direct measurement, it's just a calculation. The formula is torque multiplied by RPM divided by a constant 5252. In gasoline cars, torque, the rotational force that actually gets you moving, increases as the engine's RPMs go up. You have to wait for the engine to spin faster and faster to hit its peak power band. You feel this as you accelerate. The car pulls harder as the engine revs higher. But in an electric car, this entire dynamic is flipped on its head. Maximum torque is available from 0 RPM, from a complete standstill. It's like being hit by a massive, silent wave of power the moment you decide to go. There's no build-up, no waiting, just instantaneous forward motion. That's why the acceleration in an electric vehicle feels so shocking, so otherworldly. It's a sensation that a gasoline engine simply can't replicate in the same way. Let's look at some real-world examples that will blow your mind. Take the Tesla Model S Plaid. It boasts a staggering 1,020 horsepower. That number alone is impressive, but what's truly mind-bending is its 0 to 60 miles per hour time, a blistering 1.99 seconds. Now, compare that to a modern performance icon, the Corvette E-Ray, a hybrid with 655 horsepower. It's incredibly fast, but it still takes 2.5 seconds to hit 60. Even the mighty Dodge Challenger Hellcat, a legend of American muscle with over 700 horsepower roaring from its V8, can't keep up with a quiet, unassuming electric sedan in a drag race. So what's really happening here? How is this possible? It's not just about the peak horsepower number. It's about how quickly that power arrives at the wheels. Electric cars deliver their power instantly because of the fundamental way electric motors work. They don't burn fuel. They use powerful magnetic forces to spin a rotor thousands of times per minute. The connection between your foot on the pedal and the wheels turning is almost direct, mediated by sophisticated electronics. There's no combustion, no mechanical lag, no wasted energy lost to heat and noise, just clean, raw, and silent acceleration. And believe it or not, we're just getting started. The numbers in the electric hypercar space are escalating to levels that were once pure fantasy. The Rimac Nevera, an all-electric beast, pushes an incredible 1,914 horsepower. The Lucid Sapphire, a luxury sedan, has over 1,200 horsepower, and the Lotus Evija is aiming for nearly 2,000 horsepower. But as these numbers climb higher and higher, they paradoxically matter less and less in describing the actual driving experience. Why? Because horsepower, a term from the age of steam, simply doesn't capture the sensation of how instantly an electric car moves. Torque does. The future of automotive performance isn't going to be about louder engines or bragging about bigger horsepower numbers at the local car meet. It's shifting towards precision, intelligent control, and that incredible, instantaneous response. We're entering a new era where the king of performance isn't horsepower anymore. In this new era, torque is king. And horsepower? It feels like a relic from history, desperately trying to keep up with a future it wasn't designed for. So the next time you hear someone bragging that their car has 1,000 horsepower, you can smile and ask them one simple question. That's cool, but how fast does it use that power? Because in the rapidly evolving world of electric cars, true power isn't just measured in numbers on a spec sheet. It's measured in speed, in silence, and in the seamless fusion of technology and motion. This is the new generation of performance. This is the future of power. Thanks so much for watching and diving into this topic with me. If you found this interesting and want to learn more about the future of cars, make sure to hit that like button and subscribe to the channel so you do not miss what's next. We'll see you in the next video.